I hadn't intended to put them in any order. You thought of DNA last, so it's the last on the ring. But irrespective of this order, how would you place them in the order of their complexity?
DNA the most complex.
DNA is the most.
And proteins?
Proteins next.
Would benzene come next?
Benzene, not there.
Wood?
Plastics, which I'll give the chemical name is polymers. Now I can get rid of those three. And H2O and NaCl are really the same. So now I only got three. Oh, we've left one out. But it doesn't matter because when I have the gap, then I can fish around and find out what it is. I'm going to put...
The blackboard.
Huh?
What's the blackboard made out of?
The backbone.
The blackboard.
Oh, the blackboard. Yes, right. Right. Well, what shall I call them? Minerals, but there's other things that are going to go there too. I want to put number one in to get ourselves started, and the simplest is obviously metals. Why? Because metals are just unitary. There's all the same stuff. I mean, it's all copper, it's all nickel. They are different from the atoms because atomic iron would be single atoms, and you don't get the properties, what are called molar properties, as say hardness, strength, conductivity, density, malleability. These properties cannot emerge with single atoms. You couldn't have a single atom that had density, for instance. I remember saying this at a seminar, and I happened to be looking at the girl, but she was pregnant, so it wasn't correct to say you couldn't have density for one thing. There was already a population density in this person. But aside from jokes, metals are one atom. And then comes NaCl, salts, acids, bases, two atoms, and the methane series. Somebody said benzene, but it's part of the methane series. Now, we've got this, except that minerals does not fully cover this. It's practically all organic molecules that are not polymers. So I'll just say organic. Now we've got enough to play with here. The thing is to find the properties that describe the stages or the substages and how they apply to these chemicals. This is the game that I started playing with myself when I first did this crossword puzzle. See, I had a gap for something. There had to be a chemical that would grow. Well, I knew that DNA could duplicate itself, but that would be too complicated. I didn't realize until someone told me. I met this gentleman at a research conference. I was just then working on the book, and I was teaching myself about chemistry. I'd had some chemistry in college, but it didn't go beyond this stage of salts. And I said, is there a chemical that grows? And he said, yes, polymers. Now, the polymers literally do that. They're long chains of units. And there may be 100,000, 200,000 units long. See, we're talking about wood, with cellulose, rubber, all plastics, rayon, nylon, all of these synthetic plastics, but all of the things that vegetables make. Rubber, for instance. They're long chains of molecules, which I could represent this way as because each subunit may have 15 or 20 atoms in it, but the units are like links in a chain. Now, I was then still looking for something that moved, and I didn't get my nerve up till after the coffee to ask him, well, was there a chemical that moved? This seemed such a ridiculous thing, I didn't want to ask him. But I finally got up my courage and asked. He said, yes, St. Georgie has just discovered that actin and myosin, which are the chemicals that make up the muscle, actually themselves move. And those are proteins, and it's generally characteristic of the proteins. They have this mobility nature. The only criticism I got of my book was by a local biologist who said I didn't mention that chemicals could move. Well, I was able to say, well, he hadn't read the book because I had 3 or 4 pages about this substage of chemicals that move. Remember, motion was the character of the animal mobility stage, and growth was the characteristic of the 5th